Hey everybody, it's me again, and I'm coming to you with your e-learning lesson for Wednesday, May 6th, and we're continuing in our electricity unit. So remember yesterday we used Ohm's law to calculate voltage, current, and resistance. Okay, we established a relationship that voltage equals current times resistance. Today we're going to look at calculating electrical power. Okay, we're going to see how electrical power is related to current and voltage. All right. So you may remember we had talked about power earlier in the semester, and this is specifically electric power. Remember, power in general is the rate of doing work. But when we're talking about electric power, we're talking about the rate at which electrical energy is being converted from one form or converted to another form of energy. Okay, so electrical energy is being converted to another form of energy, and the process of that is known as electric. The rate of that process is called electrical power. So the unit of electrical power, the standard unit that we'll use, at least for these calculations, is joules per second, or remember it, watt. Okay, when we talked about power earlier in the semester. So same units, okay, so joules per second or watts. A lot of times we'll also see power measured in thousands of watts, or what we call kilowatts. And you'll see kW for kilowatts. Okay, just like kilograms is 1,000 grams, kilowatts, 1,000 watts. All right, so again, electrical power is the rate at which electrical energy is converted to another form of energy. The standard unit for electrical power is the watt, although sometimes we see power with units of kilowatts and thousands of watts, depending on what applications we're talking about. So a lot of your electrical appliances that you use around your house, stoves, blenders, washers, dryers, refrigerators, all those sorts of things have a power rating, okay? And it lets you know how much power that particular appliance uses under normal or ideal conditions, okay? So an electric stove, just for reference, uses about 3,000 watts of power. Microwave oven about 12,000 or 1,200. I'm sorry, 1,200. Remember, current. The unit we use for current is the amp, or we just abbreviate it with an A. Okay, we use an A. Voltage. Remember, we use volts, and we just abbreviate it with a V. And power, okay, for our calculations today is going to be in watts. Okay, again, watts, we just abbreviate with W. So the relationship, electrical power is equal to the amount of current times the amount of voltage. So the product of current and voltage. Remember, I represents current, V represents voltage. All right, so let's look at some examples here. Okay, so we're always going to start with P equals IV. Power equals current times voltage. So it says a blender is rated at 1,500 watts of power, and the wall outlet that is plugged into delivers 120 volts of voltage. What is the current being drawn by the blender? Okay, so what's 1,500 watts? That is the power, that's P. What is 120 volts? That's the voltage, that's V. And what are we looking for? We're looking for the current, which is I. So, plug in P, so plug in 1,500 equals I that we don't know, times V, which is 120. Divide both sides of that equation by 120. And you will get a current, okay, of 12.5 amps. Okay, 12.5 or 12.5 amps. All right. Next one says a hairdryer draws a current of 15.625 amps from a 120 volt outlet. Okay. How much power is being used by the hairdryer? Okay, so just a little background piece of information. Most of our outlets, okay, in this country, they put out somewhere around 110, 120 volts of voltage. Now, if you go to, like Europe, it's different. Those electro outlets there put out like 220 or 230 volts. So again, it just depends on what country you're in, but most of them in this country are around 120 volts, unless you have like, there's some special ones that have more or less voltage. But again, we'll go back to P equals I, which is current, times V, the voltage. 15.625, that's your I. 120, that's your V. So this is just multiplying those two numbers, right? 15.625 times 120, and you're going to find that you got 1,875 watts of power. Okay, so that's how much power is used by that hair dryer. 1,875 watts. All right. So one last one says an electric clothes dryer is rated at 3,300 or 3,300 watts of power. It draws 15 amps of current when in use. How much voltage is delivered by the wall outlet that it is plugged into? Again, we start with P equals I times V, or IV. Okay, and power, we already have it. That's 3,300 watts. And we pay attention to the units so we know which quantities we have. Okay, it draws 15 amps. Remember, amps, that's current. That's I. How much voltage? So we're trying to find V. So plug in 3,300 for P. I is 15. And V we don't know. So we're going to divide both sides by 15. And what we will find is that our voltage is equal to 220 volts. All right, so actually dryers are an example of an outlet that example of something that's plugged into an outlet that would have more than that standard 120 volts. Again, they draw a lot more. They have produce a lot more power and draw a lot more current. So they have a a larger capacity outlet that has more volts. So 220 volts would be the voltage based on the power of 3,300 and a 15 amp current. And with these calculations, we always go back to the power being equal to the current times the voltage, and given two of those quantities, we can calculate the third one. All right, and so you will have a Schoology assignment involving some of these types of calculations in the folder for today's e-learning. Okay, until next time, we'll see you later.